So welcome everybody to this latest GCSE revision video on 162 Maths, and in this video we'll be doing a AQA topic test on the higher syllabus focusing on standard form. Now as always there will be a copy of the question paper in the description below for you to download and have an attempt at before we go through the answers by watching this video. So let's get started on this topic test on standard form at higher level. Now there's been no indication of whether this question paper is calculator or non-calculator, so we'll just go through a calculator just to speed things up. However, just be wary that obviously if you do get them on a non-calculator paper that the questions would be worth considerably more marks. So looking at the first question, it says here are 5 numbers, and what the question is asking us is to work out the difference between the largest and the smallest numbers. So first things first, what we need to do is write all the numbers in ordinary form, just so we get a clearer picture as to which is the biggest and which is the smallest. Now this step isn't really essential, but again it's something that you may want to choose just to make your life a little bit easier in terms of working through this. Now in terms of once you've got the numbers in the same format, it's just a case of recognizing which is the biggest and which is the smallest. So this number here is our smallest, and which number is our biggest? Well, it's going to be this one here. So what we then need to do is 2, 8, and then with 4 zeros, which is 280,000, and we want to subtract 5,000 from that answer, and then what we then get is 275,000, and because we're taking away 5,000, and then we then want to write this answer in standard form, so it's 2.75 times 10 to the power of 5. Then moving on to our second question, it says work out 5.9 times 10 to the power 7 divided by 2.3 times 10 to the power 4. So again, going for our calculator, let's start by entering this in. Now I would strongly recommend using the standard form button on your calculator, and again, so the only thing you need to do is type in the power, and divided by 2.3 times 10 to the power of 4 equals, and it's given us a really long decimal number. Now the question is asking us to give the standard form number to 2 sig fig, so that's going to be 2.6. So if I just write down what the answer is, so it's going to be 2,600, so you need to convert this number into standard form, so it's going to be 2.6 times 10 to the power of 3. So looking at question 3, all we're doing is just asked to solve this equation. Now all I need to do here is take this 0.2 over to the other side, and how do I do that? Well, I do that by not using a highlighter, but by multiplying this by 0.02. So what I'm typing into my calculator, that x equals 3.1 times 10 to the power of minus 4. Put that in brackets, and that's going to be multiplied by 0.02. So if I reach for my calculator and do just that, so 3.1 to the power of minus 4 multiplied by 0.02, press equals, and I get an answer of 6.2 times 10 to the power minus 6. So 6.2 times 10 to the power of minus 6. So looking at question 4, it says that in total tourists visiting a country spend 5.2 times 10 to the power 8. On average, each tourist spends £645. How many tourists visit the country? And it says give your answer in standard form to an appropriate degree of accuracy. So looking at this, we've got 5.2 times 10 to the power 8, and we're dividing that by 645. So if I type that now into my calculator, so I've got set up my fraction, 5.2 multiplied by 10 to the power 8 divided by 645, and it gives me an answer of 806,201. Now in terms of the suitable degree of accuracy, I would pretty much say that that should be okay. So let's have a look at, so we're writing as 806,201, it's the nearest whole person, and what we then want to do is round this up to into standard form. So I would probably go for either, and again you could have either of these answers. You could write 0.062 times 10 to the power of 5, or you could write 8.06 times 10 to the power of 5. So again, in terms of the degree of accuracy, I would go for one of those two as your answers. Moving on to question 5, it says here are the probabilities of two events. So it says event A has a probability of 2.7 times 10 to the power minus 2. Event B has 3.4 times 10 to the power minus 4. How many times more likely is event A than event B? Now to do this, all we need to do is just simply divide the two. So here we've got 2.7 times 10 to the power minus 2 over 3.4 times 10 to the power minus 4. Again, if I reach for my calculator and just simply enter that in, so I've got 2.7 the power of minus 2 and then 3.4 times 10 to the power of minus 4, press equals, and it gives me an answer of around about 79.4. So I would say round about 79 or maybe 80 times more, depending on how you want to work it. Now in terms of 5b, it says work out the probability that only one of the events is happening. So for this, all we need to do is basically just multiply out the probability. So here, work out the probability that only one of the events is happening. So either you can have event A and not B, or what we could have is B and not A. So what we've got to do then is working this out. So let me just have them both on screen. So for this one, we've got 2.7 times 10 to the power of minus 2 multiplied by 1 minus 3.4 times 10 to the power of minus 4 plus B happening, which is 3.4 times 10 to the power of minus 4 multiplied by 1 minus 2.7 times 10 to the power of minus 2. And then all I then need to do is type that all into my calculator, in which I should have an answer of 0.0273216 and converting that into, well, rounding that up to 3 sig fig as it's asked me to, I'm going to get an answer of 0.0273. That's my final answer. Then moving on to question 6, which I think is our last question. It says in the body the ratio of the number of red blood cells to the total of all cells is 5 to 9. It is estimated that there are 3.72 times 10 to the power 3 cells in total. Work out the number of red blood cells. So in terms of this, what we need to do is, well, in terms of red blood cells, at all red blood cells, we've got 5 to 9, and we've got the red blood cells, which is what we're trying to work out. We know that this number is 3.72 times 10 to the power of 13. So what we need to do is do 3.72 times 10 to the power of 13 divided by 9 to work out what the value of one part is, and then we multiply that by 5. And so let's type that into our calculator now. So I've got 3.72 to the power of 13 divided by 9 is equals, then multiplied by 5, press equals, and I get 2.066 recurring to the power of 13. So in terms of for an appropriate degree of accuracy, let's get that answer back up. So I would say either an answer of 2.07 times 10 to the power of, let me just get that calculation back up, 13. Or you can write it as 2.1 times 10 to the power of 13, or you can write it as 2 times 10 to the power of 13. Now, in terms of the decimal number, when you're multiplying it to the power of 10 to the power of 13, it's really not going to make that much of a difference in terms of your A value. So any of those would get you, or should get you, 4 marks in this particular question. But usually when it does say to appropriate degree of accuracy, you can choose, but I would say either go for 1 dp, 2 dp, or maybe 0 dp, depending on the contents of the question.